Suppose that we know for some function h of x, the integral of h of x plus x from 0 to 4 is 12. The integral of x squared minus h of x from 3 to 4 is 1/3. And the integral from 0 to 2 of 2h of x is -10. We want to evaluate just the integral of h by itself from 2 to 3. So all these other ones have something being done to h. So we'll probably have to rewrite using properties. We have some actual functions in here, so we'll probably have to find some antiderivatives of those to help us simplify things. But ultimately, we want h, we want the area under it from 2 to 3. Now, looking at all the other bounds that we've got 0 to 4. So 0 to 4 is kind of the biggest one. So we've got the whole space. 4 to 3, we've got that. We've got a little piece there, so we've got that filled in. And we have 0 to 2, so we know that. The one we're missing is exactly what's in between. So just using sort of very basic definite integral properties, 0 to 4 can be broken into 0 to 2, 2 to 3, so the one we want, and then 3 to 4. So what I'd like to do is get this, the integral of h from 0 to 4, then h from 0 to 2, and h from 3 to 4 from the given information. And then we'll be able to rearrange, just use basic arithmetic to get the missing one. Okay? So that's what we're going to do. All right, let's copy the information. So from 0 to 4, h of x plus x, we get 12. H of x plus x, we get 12. What else did we have? From 3 to 4, x squared minus h of x, we got 1/3. And we had one more, which was 0 to 2, and that was 2 times h of x. Gave us -10. So the first thing I can do right away, I can bring that 2 out. I will sort of, so I don't have to keep bouncing back and forth, say, we're looking for this one. We're looking for it from 2 to 3. And I want to double check, was it 1/3 or was it -1/3? Okay, it was just 1/3. All right. But everything else looks fine. So I'd say the first thing to do, probably the easiest thing, bring that 2 from the 2h of x out. And then divide by 2, so the integral from 0 to 2 is just going to be -5. So I've got one of the little pieces of the puzzle. Okay, what to do next? I'll start with the big one here. I think we're going to need another page, so we'll get that, just because I don't want to cram everything down into that bottom corner. So we have h. I don't know how to deal with h, but x is a function I recognize. And one of our definite integral properties says, well, you can split a sum into a sum of definite integrals. Okay, so now, oh, hey, there's the thing I want, and then, well, I know how to integrate x. I know how to get that definite integral. So thing I want, and then what do? So x goes to x squared over 2. We're going to plug in 4. We're going to plug in 0. So that is x squared, so 4 squared over 2 minus 0 squared over 2, right? That's how we evaluate our definite integrals. Plug into the antiderivative and take the difference. So that'll be 0. This is 16 over 2, so 8. So 12 is the big integral 0 to 4 of h of x plus 8. So subtract 8 from both sides. We have another piece of the puzzle. Okay. Oh, let's not forget our dx. Doesn't look like it's doing anything, but it's always good to be in the habit of using the proper notation. So the last one we need is we need to get the integral from 3 to 4 of just h. Well, right now it's trapped with its buddy x squared, but that's okay. Let's grab another sheet just so we have enough room. So 3 to 4, x squared. Well, x squared is also a function I recognize. And I also know that definite integrals split over subtraction. So I get h of x here. And I know how to integrate x squared. So you increase the degree by 1, divide by the new degree. And because it's a definite integral, we're going to evaluate between 3 and 4. And then take away the thing we want, and you get 1/3. So what is it? 4 cubed, so that's 64 over 3 minus 3 cubed, which is 27 over 3, which is really just 9. But actually, I'm going to keep it as 27 over 3, so that way I can take the difference. 64 minus 23. I don't want to fumble this, so I'll just do it off to the side. So 7, so 37. So 1/3 is 37/3 minus our final missing integral. So subtract 37/3 from both sides. You'll get negative 36 over 3. So that's going to be negative 12 is negative of my integral. So let's drop the minus sign, and we see 12 is the integral of h from 3 to 4. So now, as we were saying earlier, using definite integral properties of being able to introduce sort of a third endpoint, this integral, which we know is 4, is the integral from 0 to 2, which we know was negative 5, plus my mystery integral from 2 to 3. And then we got to finish up. We got to get to that 4 endpoint. So plus what we just found, which was 12, the integral from 3 to 4. So negative 5 plus 12 is 7. So 4 minus 7, negative 3 is the value of my mystery integral. And there it is, all done.